A big thank you to ACS for all the work that you do, including, of course, these awards for the past 30 years. Um, it's always a little bit of a challenge to be the final presentation. I'm flattered and honored to be amongst so many incredible innovators here. Uh, this is what we're going to do. This is what Future Origins is setting out to do. I like to think that part of the reason that we won the award is because we had the longest title for an award submission. But the fact is, this is exactly what we're aimed at. If you go into any supermarket or drugstore, a huge percentage of the products there are made with ingredients that come from palm oil. And palm carries with it a whole set of challenges. Environmental challenges, sustainability challenges, societal challenges, deforestation, all kinds of things, huge amounts of greenhouse gases. And so we asked ourselves, is there a way to make the exact same widely used ingredients that traditionally start from palm oil, but do it a different way using biology, biotechnology, fermentation, and plant-derived sugars? And so that's what Future Origins has set out to do. And right button. So Future Origins, we're the specific widely used ingredient that we have focused on to start are C12, C14 fatty alcohols, a product that's used in over 3 million tons per year worldwide, a market worth several $billion. We are driving toward our first commercial scale plant in the Midwest US that will produce over 50,000 tons of this ingredient. Future Origins was set up as a joint venture leveraging technology innovations from Genomatica that some of the folks in this audience may be familiar with. Genomatica has received a few of these Green Chemistry Challenge Awards in the past for its innovations, but decided that the best way to commercialize these innovations was to surround ourselves with some of the heavyweights in this worldwide industry. And so as a result, Future Origins was formed as a joint venture with investments and partnerships with Unilever, Cow, and L'Oreal. And the backing of those parties has been incredibly useful in advancing our technology and market entry. What you see here on this slide really tries to capture really the life cycle of what it has taken to develop our products. On the left-hand side of the screen, you see really a focus on engineering of microorganisms to eat sugars and to produce the target chemical of interest. That is married to overall process design, and when trying to make a chemical that's in such high volume and is such at commodity prices, it's really important to co-engineer, co-optimize the process at the same time that you're developing the organism so that you can really shave every single penny from the ultimate production cost of the target chemicals. We use renewable feedstocks. These are plant-derived sugars. The specific starting point will vary around the world. In the Midwest, a natural starting point is corn, dent corn, or industrial corn, as some people call it. And then we've taken the responsibility, now that we're already at demonstration scale, to do the next level, the detailed engineering work, to go ahead and create that first 50,000-ton commercial plant. On the right hand, you see some of our partners. I'll highlight, though, that despite the incredible support of our initial partners like Unilever, we are not what would be called a captive joint venture or a closed joint venture, but rather the intent has always been, both with the first plant and with the ones that will follow, to make that available to companies outside of the initial set of partners. So this is meant to have substantial worldwide impact and really revamp value chains. A little bit about some of the progress that we've made, which you see in the center of the slide, and also some of the challenges that we've worked to overcome during the development. As you can see in the center, we have already advanced from lab scale work through pilot And for those familiar with fermentation technologies, our pilot work done probably almost 2 years ago at this point was already done at a scale of 63,000 liters, which, for many products, that's beyond what they even run commercial scale reactions at. So we were serious about driving towards the kind of commercial scale targets that we needed. We're now at the point where we have created many tons of product for product sampling by initial customers worldwide. We have validated product quality by multiple demanding customers within the value chain. And now we keep progressing on a path towards ultimate commercialization. The challenge, and I won't go into a lot of detail here today, happy to answer questions later this evening, but if you think about the biology aspects of this, and imagine a metabolic cycle that's trying to add 2 carbons at a time to create the ultimate compounds that you want, you have to know, when do I get off of that merry-go-round and end up with, okay, here's how much C12 I want spit out, here's how much C14, and those things need to be in balance. And those require some pretty interesting engineering and optimization to get product that meets industry spec for something that's intended to be a complete drop-in, which accelerates market adoption. Similarly, all the work needed to maximize the amount of FALC production, fatty alcohol production, and achieve near theoretical process performance, super important, again, driven by market requirements of being able to compete effectively with widely used commodities that are pretty darn inexpensive, okay? So all of that process optimization work, super important. The other kinds of challenges, I'll just highlight one, kind of a fun one. We have a fairly unusual fermentation broth. If you think about when you have an oil and vinegar salad dressing and the need to shake that up, here we have a fermentation broth that has an aqueous component, an oily component, and then also something that's kind of in between, an interphase component. And so the idea of how you separate things to have useful downstream processing and maximize recovery, that's really important to figure out, the last final percentage there. Lastly, in addition to all of the technical progress that we've made and are proud of, we've had equally important commercial progress. So one of the things I like to highlight is simply that even though the commercial plant is a few years off, we have already publicly announced that we have signed binding offtake agreements for a majority of the production from commercial plant number 1. And it's things like that that will facilitate our fundraising for going ahead and making plant number 1 a reality. And with that, let me offer a big thank you.